I'm Bob with CNC Molds N Stuff. I'm a hobby, hack, self-taught machinist. Well, self-taught with the help of 10 million people on the internet anyway. If you look behind me, you'll notice a couple of small high-speed CNC milling machines and a decent-sized lathe. That's a 14 by 40 back there. The camera's sitting here on my assembly bench where I put molds together for customers. And just outside the doors behind the camera is my bigger, or big for me, Herco KMB1 milling machine. Today, we're not going to be talking about any of that stuff. I'm going to try to install a little machine shop, universal 3C collet closer on a Harbor Freight 31316 small lathe. It's an 8.5 by 18. I think it's bigger than anything that Harbor Freight sells currently today, but it's still a pretty small lathe. Anyway, I'm going to head on out to the back shop now and leave you guys to look around the machine room for a second. And there she is. Ain't she beautiful? Oddly enough, I use this lathe almost every day during the week to do one simple task. I insert an alignment pin. Well, it's just a stainless steel dowel pin. And I use a hand ground high-speed steel lathe insert. Well, that's what that spring's for. Make sure I don't do anything stupid. To make a simple radius on the end of that pin. These pins are used in molds so that the two plates align, and the radius on the end helps them go in a little bit easier. So why in the heck do I need to put a collet closer on this? It's not going to make it that much faster to operate. I actually need to put a radius on the ends of some Teflon pins for an application, and I'm afraid I would just crush the Teflon rod stock in that 3-jaw chuck, so we're going to change it out to a little machine shop 3C collet closer. Let's see how that works. I actually cut the box open yesterday, but I haven't actually pulled anything out of it, so I'm not sure what's in it. My invoice, a catalog of other stuff they want to sell me, a whole bunch of air, set of 3C collets. I've never seen a 3C collet before, to be honest, so let's look at one and see what it is. What a cute little guy. Looks just like a 5C collet, only smaller. Let's set the collets aside since we won't need those for a while. See what else is in here. I'm guessing this is the closer. And this looks like what's supposed to be an adapter to adapt a 3MT, or a number 3 Morse taper spindle, to 5C. Ooh, yuck, there's cosmoline all over it. I'm going to have to go clean that. Alright, I'm going to go clean the grease off of this adapter, and I'll be back in a little bit. Alright, there we go. All nice and clean. Wrap it up in that to keep the dirt off while we're working on everything else. And I suppose the next thing I got to do is get this chuck off. I don't know why they do that, but a lot of these small lathes, well, I don't know about a lot, the two I have, are both nearly impossible to get a standard hex key in there to pull the bolts. I've got a cut-off one here somewhere that just barely fits in there, and of course I can't find it. I'll be back. I may have to cut one off. Here we go. One sawed-off hex key. Let's get this chuck out of the way and see what we're dealing with. Oh, first thing I should do is unplug it. As soon as I remember which cord that is. There we go. Alright, now let's get that chuck out of there. Still at it. Got the screws loosened up a little bit, but they're getting to the point where I can't quite get to them with a wrench. So I actually have to move the chuck off the faceplate so the bolts move forward so that I can continue to get the wrench behind them to continue to loosen them up. Just isn't any room back there. I already knew that because I've had a 4-jaw on here for a while, and I just put the 3-jaw back on because it was faster for radius in the pins than the 4-jaw, so I didn't have to dial it in. And the radius isn't critical. Just has to be smooth, which is a function of my tool grinding, not a function of the lathe. There, we're starting to loosen up. All right, and finally, hopefully, we'll be able to pull this thing off. Even though I will probably never install this chuck again, I thought that once before. So I'm going to make sure I save these bolts by screwing them into the back of the chuck. So that wherever I store the chuck away, the bolts that match it up to the machine I used it on are right there. Alright, let's set this thing out of the way. Get any idea what we're looking at. Oh, that's nasty in there. Well, I'm probably not going to do anything more than dress it with a little emery cloth, because to be honest, we're not after anything precision here. We're just after maybe a little bit quicker putting pins in and out. And the main reason for installing the collet closer is so I can support softer stock like acetal and nylon and Teflon rod stock and things like that that the 3-jaw or the 4-jaw chuck would probably crush. Let's get this tool out of the way so I don't cut myself on it. Back the saddle back. And go find ourselves a little piece of sandpaper to lightly dress the inside of that. Alright, here we go. Just a little light cleanup. Plugging it back in. Now, I will tell you, putting my finger in that hole with this thing spinning scares the hell out of me. So the first thing I want to do is make sure I kind of got a nice attack and get my hand out of there easily. And I'm definitely not going to push the limit, because that would be a painful end to the day if I got my finger stuck in there. Now to clean up any grit. Same thing. Now I actually kind of want to clean that up, or at least wipe it out a little bit deeper back than I'm comfortable reaching with my finger. So let's see how this works out. It looks pretty in there. I'm curious to see how bad the center of that spindle is. So I'm going to go get a dial indicator and see if I can't get one set up to check it. Alright, here we go. We've got a stand and a test indicator. I think I'm going to move this tailstock back a little bit. So that I can use the carriage as a place to set the indicator stand. This indicator stand is probably older than you are. I'm sure it's older than I am. It belonged to my grandfather, who was in manufacturing during World War I and World War II. He was born before the turn of the last century. Just, you know, when I was younger, that didn't really impress me much. But it has become something that I find interesting. I kind of like this indicator stand. So you just position it close to where you want it. And then it's got this little adjustment screw that you can turn down or up until you have a reading close to what you'd like to start at. Alright, this doesn't show the indicator, but this little knob right here, spring-loaded lever, allows me to just raise and lower the indicator, the arm that the indicator is mounted on, until it's at a nice convenient location for me. You're just going to have to take my word for what it says, because I don't have a good place to set the camera to show you the indicator. But it's an old Starrett last word, model F. And we're going to turn it and see what we get. Oh, we can't be touching with that. That was just too good. Alright, we're at 0, and I am rotating the chuck, and I can't see any movement of the needle, which means I must not be touching. Nope, it's touching. Well, at least according to this indicator, we've got hardly any run out on the inside of that bore, which is incredible. It's not at all what I expected from a inexpensive Harbor Freight lathe, even a 30-year-old one. I'm going to do something. Alright, well, when I fired it up, it moved about 1/1000th, and it just stayed there. Let's run it in reverse. Alright, the needle is quivering a little bit. Maybe only 2 or 3 10,000ths. I mean, I think I'm getting more movement from frictional movement of the whole assembly than I am from runout. Of course, to be fair, that indicator is as old as the stand. That was also my grandfather's. I've got some newer indicators. I just enjoy using this old stuff from time to time. But if that indicator is any indication, that's a really good spindle bore. Now let's see where my parts went. Ah, yes. Nope. Yes, here we go. Alright, I'm just going to set this up here and just kind of see how it goes. Feels really good. I mean, it feels really good. Alright, I got the lathe moved out to the front edge of the bench. Not particularly crazy about having it there, but I needed to do that in order to open the door. Alright, one advantage to having to move the lathe out is it gave me a position that I could put the camera, that you can see the indicator in the bore of that collet adapter, that Morse taper number 3 to 3C collet adapter. And I went ahead and tapped it in just so that I could see, you know, how well it runs out, you know, more or less properly installed. And it's not bad. I get a little bit of friction movement when it first starts up, but I'm hardly seeing any quiver at all. I'd say it's about the same as the raw spindle bore was. When it first starts up, you get that friction movement, but then it normalizes, and that amount of movement is maybe 3/10,000ths. That's only about a 10,000th more run out than the raw spindle bore was. So it's a lot better than I first thought. I still need to figure out how to do the rest of the installation though. Alright, it seems to be fairly straightforward at this point. The collet just goes in, you have to align it to the aligning key. And when you screw in the tube, or screw the tube onto the collet, notice the handle's off, the collar that goes on the back is off. What it does is it pushes against the back of the adapter and pulls the collet back into the adapter to lock it in place. And the adapter itself appears to be strictly a friction fit and nothing else, so tapping it in was the way that it goes. I just assumed that that was going to get pulled in with the collet over time, but it looks like it's just a straight friction fit, just like the MT2 taper is in the tail post. Live and learn. Of course, I'm not a real machinist, as just a self-taught hack with the help of 10 million friends on the internet. Alright, I'd still like to shorten this up. I don't want all that extra space sticking out there. So what I'm probably do is cut it off about here somewhere, and then turn it down to there so that it sits nicely on the back of the headstock. Now, if only I had something to mark it with, like a hacksaw or a Sharpie marker. Oh, just happen to have one here in my pocket. Let's hope I can see that mark. And you know that other lathe I said we weren't going to do anything with today? I think I'm going to use it to do this part. Alright, let's light this thing up. That's just a piece of stock I threw in there to turn a center for aligning my tailstock. Doesn't have anything to do with this project. I can hear people cringing now because I left that chuck key in the chuck. I think the first thing I'm going to do is cut it off with a little bit more length than I need between this mark and here to match this length. Although I think that's adjustable, or it's fairly flexible. Don't ask me about speeds and feeds and whatnot. I just have standard setting for a lot of stuff that just seems to work. Alright, let's give a little extra. We can always cut it shorter, but it's kind of hard to cut it longer. And this is for the guy who says he's afraid to turn on the power feed when carving. I'm just being a smartass. I know you got a lot more experience machining than I do, guy. And some of the knowledge I have about machining has come from watching your videos. All right. I suppose next we need to get the approximate diameter of that stub, so I know what I'm going to turn it down to. Alright, well, here's that big lathe we weren't going to use today, being used to turn that down to still about 2 or 3 thousandths over, but it's probably fine because it's just a loose fit for that collar and that handle. I think we'll go try it on the small Harbor Freight lathe and see how it works out. Before we go anywhere, knock off those burrs with a file. Well, that feels better. Okay, now we'll take it over and see how it fits up on the other lathe. Didn't see any reason to remove the adapter or the collet we were testing with. And just for now, I'm going to leave the door open so I can get a feel for the fit up. Alright, it's pulled up against the collet. Got that set up there. Let's find our hex key. I'll spot this, well, I'll use a transfer punch to make a mark, and then I'll spot these for the set screws later on if the set screws don't make their own mark right now. That feels pretty good. Once I figured out what the heck I was doing and stopped being afraid of it, it was pretty easy to install. I think it's done. Now let's see how easy it comes out. I'm going to move the camera on you guys. Everybody with motion sickness, look away. doesn't come out quite as easy as I would hope. To be fair, it's a very small nub to try and get a hold of. Yeah, it comes out easy enough. Put it in. Tighten it up. And give it some serious... I buy these pins by the thousand, so destroying one pin doesn't bother me as much as a device not working would bother me. That's actually pretty good. And it pulls right out. I guess it wasn't too bad to install the little machine shop universal collet closer. I just needed to get some confidence in what I was doing and do it. All right, let's turn a pin. See, one problem, I can't do that unsafe thing of grabbing the chuck to stop it anymore. I do believe it's going to be faster, and that's not even the main thing that I installed it for. Probably blocking the video with my arm, huh, guys? Wow, I'm pretty happy. Let's do some basic testing now. Let's throw a pin in there. I know these pins aren't great. Hey guys, the battery's just about dead, but I wanted to show you the old 100-year-old indicator on that 30-year-old lathe. Amazingly, still with only a few tenths run out on a generic pin. Wanted to make sure you guys could see the truth. As they say, it's the last word.